February 20, and welcome everyone on an open technical forum of Trusted Firmware M. And today we have two topics in our agenda. One of them is a fuzzy tool developed by Gary, and he will present in a moment. Another one is an open discussion for SFN session, in general, the dependency on a linker and compiler. So I hope we will have time to cover all of them, both topics. If not, we will move the compiler topic to the next session. Yeah, the first one is a fuzzy tool. Gary, please.
All right, fuzzy sounds pretty appropriate at 1 AM. Okay, cool. Let me try to share something. Actually, let me go into presentation mode and then I will attempt to share. Don't go into presentation mode until you've shared, I think. Okay, let's try this again. Excuse me, bear with me here. It doesn't let me get out of presentation mode. Oh, okay, stop. No. No. Where is the get out of presentation mode button? Is it over here? No. Get out of presentation mode free. Okay, here we go. I am out of there. Share something. Here we go. Share screen. Session 1. All right. Let me know if you...
I can see your email.
All right, my email. Well, don't do that. Let's try screen 2 then. Okay. And is that okay? I think this is a presentation.
Yeah.
And let's go into slideshow mode. All right, does this look like a title page?
Good.
Looks like a title page. Okay, cool. All right, so yeah, I'd like to talk with you about a TFM fuzzing tool that I've been working on past 2 or 3 months or so. Luckily for me, Shibu found out that one of the, oh, can you guys hear me okay? Just want to make sure. Yep. Okay, very good. Okay, cool. Yeah, so Shibu found out that one of the certification labs in China is, they want to make a fuzzing tool for TFM at the PSA level, proprietary one, and we, of course, being open source kinds of people, would prefer to make a tool available and for anybody to contribute to and make good use of. And I'd like to tell you about that tool. That it's something that I've been working on, and it is very much at its earliest stages. I should clarify, but it could be useful not only for TFM but also for TFA in the future. In concept, all you have to do is just replace a boilerplate, as I described it, code snippets file. Don't even have to recompile in concept anyway, and you've got SPCI, TFA SPCI testing available. So could be hopefully a very useful tool. Right, so originally this was going to be a little different from how it has turned out. Originally I intended this to be a sort of a generic TFM application running on the target system that, you know, generates code like any other set of regression tests. Its main goals were to, first of all, make it as easy as possible to write a whole lot of tests quickly. And another goal, of course, was fuzzing, so, you know, random testing. Yeah, I wanted to also be able to check for security breaches, data bleeding between assets, PSA assets. and accumulate test cases within, into a regression suite for TFM. And I noticed there were some concerns. I started having some concerns about having this target-bound test interpreter. And so I ended up instead going with a host workstation-based code generator, for now at least, rather than a target-bound interpreter. Mostly for the reasons, 3 reasons on the left side of the slide here. First of all, a lot of TFM-based, targets tend to be pretty small, have a very, pretty small footprint available, and the way to minimize the footprint is to do all your thinking, so to speak, on the workstation rather than on the target. And so that's that minimizes the requirements on the TFM or TFA target. Another reason to go with a target workstation-based thing, of course, is that we do have infrastructure already in place for running regression tests in this that are, we generate manually, and this would be simply a means of doing such tests in an automated way. And another reason why it made sense, at least to start with a host workstation code generator, is that it's probably a whole lot easier to make a code generator on the host that can do both TFM and TFA than it is to make a target-based system for TFM and another one for TFA. They kind of have to be pretty different because obviously TFM and TFA have very different infrastructure. But of course, there are also trade-offs. It's a trade-off, so there are reasons to prefer doing a target-based test interpreter, I suppose you could say. One, of course, is that the download time for tests generated on the host workstation is unfortunate. Now, part of the ways we can work around that, of course, are by generating an entire test suite so that your download time gets you a whole lot of tests. And right now, currently, it only generates a single test, but the intention, of course, is to generate an entire suite. Another reason why it's better to have stuff on the control of the tests on the target instead of in a host is that there are some predicted results of a test that are hard, especially in the extreme case of a multiple targets, multiple threads, I should say, running on the target, vying for resources, for PSA resources. It can be very hard to predict what the timing is going to work out to be. Georgie also pointed out that there's no one single flash programming mechanism, so that it's hard to standardize the downloading process. But it's ultimately kind of a trade-off. In the long run, we would like to have a cooperative mechanism of some sort. And we'll start with a host-based code generator, but hopefully we can, in the long run, make a more balanced arrangement, cooperatively managing the process between the host and the target system. So one thing we could do once we start with this host-based code generation, we could then add a plugin-based mechanism so that you can do more things on the host, and it can be customized to what the particular partner needs. Like, for instance, if they are adding something of their own to the PSA API, we could run those tests of what they need of their additional stuff in among the tests of PSA itself. and see how they interact, hopefully badly, because we want to catch bad behavior. Another thing we could do is we could create a RAM-based downloader of, so that it's much more quickly a serial line type downloader, so that you can load tests much more quickly than usual Flash programming times. Another thing we could do as a cooperative management between the host and the target was we could create a target-based agent that can run the same test, loosely speaking, but re-randomize a bunch of stuff so that it'll run tests multiple times, but re-randomize the data and some other aspects of the test and run it multiple times for each time you download it. So there's a lot of ways we can generalize this, but for the moment, it's just it is for now strictly a host workstation-based code generator. But obviously, the whole point of open source is to make things more flexible wherever possible. So I describe this thing as templated because, well, I'm borrowing a term from ARM's Raven, as it's called, tool. The Raven tool is a well, it's a CPU fuzzing tool, and to use Raven, you write what they call test templates, and a test template doesn't describe what exactly happens on a test. It describes instead more the general schema of the test. The sort of thing that you really want to do is, for random testing, is broadly of the nature of creating a comparatively deterministically create a certain test environment of interest, and then comparatively randomly set loose, play around, so to speak, in that environment and see what happens. If you instead create a bunch of totally random calls, PSA calls, or you're going to end up generating a whole lot of errors, and it certainly is important to be able to do negative testing, so to speak, checking to make sure that you generate correct errors when you do bad things. But hopefully by the time you get to the stage of fuzzing, you will mostly be doing correct behavior. So you want to make sure that you get your normal nominal behavior correct, as well as negative testing. And I'll do a demo which shows some negative testing as well coming up. Yeah, right. One, as I presented this earlier at ARM, one question that came to mind was to what degree it's best to come up with a high-level abstraction language for describing the tests that you want to run versus a general purpose language framework like Java or Python or whatever. The advantage, of course, of doing Java is, or Python or whatever, is that you can do anything you want, right? And so that's really great, and we kind of need to head that direction over time, but it's also very valuable to have an abstraction, I suppose you could say, that's very well focused toward the particular testing at hand. One of the downsides is, of course, the size of the target, code that you have to do for that kind of thing. Although Georgie pointed out that MicroPython can be pretty small, so it may not be a huge burden on the target to have a general purpose language running on it. But an unfortunate downside of deploying a general purpose language is, although you can do pretty much anything you want, you also must do everything that you want. So thus is the curse of the general purpose language. How do you make a wooden ship kit? Well, you supply a block of wood and then tell them to carve away everything that doesn't look like a wooden ship. So it's yeah, you can do anything you want, but the problem is that you have to do anything you want yourself. You don't get any help. So at least at first, it seems to make more sense to come up with an abstraction for tests that makes it really easy to generate a whole lot of tests quickly. And that's the immediate goal for now. And let's see, yeah, so that's what I'm targeting here. There's, as I mentioned, a templating language in which describing the nature of the test. And this is sort of a, I guess you could say loosely, very loosely speaking, a syntax chart of the command language. And I'm going to go ahead and give you a demo of how to use this language to generate tests. But the general gist of it is you create a series of commands in this template input to the code generator, and they consist, generally speaking, this is abbreviated of course, but of an operation to perform on a PSA asset, a particular asset type. After that, then a selector for the particular asset that you want to operate upon. And that could be, as you can see, by a name or a UID in the case of secure storage. And then after that, you have parameters, various parameters in order to describe what you want, what you want to do with that particular asset. And then finally, at the end, you can, if you'd like, optionally specify expected results of that particular command. And yeah, so for instance, you could do a command of the nature of set an SST secure storage asset named certain name and give it this data and expect it to pass. Or, for example, that's just one simplistic example, but I'll go ahead and give more examples of that in a moment. But first, a reminder that when it comes to fuzzing, you're not only on the hook, so to speak, to generate random activity. You're also, that's only half the job. The other half of the job is that you have to know what the expected results need to be. So you need some form of a modeling type of functionality to detect when something is misbehaving. So that's the two things to be done. In some cases, it's easier to predict what's going to happen on the target, as I was mentioning earlier in the case of multiple threads, for example. But of course, anything you run on the target has the disadvantage that if the target goes insane, then you're not necessarily going to be able to trust the expected results that a target generates. So that's one thing that's kind of nice about running a generator on a host, is that we have at least a little more confidence that the host is going to stay sane, or at least in concept. But in any case, right. So I'd like to do a demo here. Need to obviously point out this is new, right? So it's vocabulary. This code generator's vocabulary is of PSA calls is it's still kind of small. I have written, there's code in there for crypto, but I haven't really tested it much yet. I've mostly been working with it on secure storage so far. But again, I'd like to bring this into the open source domain and get some more brain power on it. Yeah, so what I'll do in this demo is first I want to emphasize I'm going to start out with what I just want to call party tricks, in the sense that the point of them is just simply to demonstrate that you can create a whole lot of test code with a very small amount of input, which is, again, being able to generate a lot of tests in a very short time is with very little effort is a very valuable thing. But but at first, the examples I'm going to show you aren't very exciting, but they will get more interesting as I progress through the demo here. I will, after a few very simplistic things, I will point out that the fuzzer can infer correct test outcomes for you, which again was back to the fact that I was just saying a moment ago about being able to generate random activity is only half the problem. And then I'll show that it can generate randomized data and asset names. I'll move on to multiple assets in a single command and so forth. So yeah, right. So yeah, get on with the demo, right? Let me see if I can switch over to my demo screen here. All right, can you see a text editor and a well, as it turns out, it's a Sigwin command line.
I can see two screens, white and black one.
Okay, excellent, very good. So of course, this is on the black one, black background one is just a Sigwin bash line. What I have is in this sort of a demo directory, I've got this cheesy little nothing to it bash script here, which simply clears the screen, prints out the test case that I'm running, and then spaces down a little bit and runs the test and shows the output of that test. I'm running it with this dash verbose flag here so that it narrates some of the thinking that the code generator is doing. And I'll refer to that occasionally, but not very often. Mostly importantly, what you want to see over here, I'll make it real easy to run, so I'll just say R1, for example. So here's a really, really simple example test, which is, again, the initial ones are not very useful, but it's just illustration, right? So it starts out with a line called purpose, so it just simply describes the purpose of the test. And it just creates an SST asset UID, unique ID 104, and with this data, very simple test, very boring test too, and it expects it to pass. Okay, what code does that generate? Well, here it is. As you can see, it generates quite a lot of code, test code, and this basically just creates data for that particular asset, which is just exactly what I described, very simple test. And knows its size. It then creates a call to create that asset and expects it to return success, checks that it returns success. And then it cleans up after itself because we don't want to leave junk behind in the flash. So it cleans that up and then terminates the test. If it gets that far, it says it passes. Okay, boring example, but just to illustrate that you can create a lot of test code in a very small thing. But if you make a somewhat larger, here is a still not a really huge test case. This is just to quickly show you that you can generate a whole lot of test code with a fairly small amount of stuff. I won't go over this particular case, but I just want to show that a template can be very simple and yet generate quite a lot of test code here. I'm not going to go over this case right now. I'll go do some more examples. But it does generate a whole lot of code, and it changes if you rerun it with a different seed. You got considerably different code every time you rerun it. You can see that the data it generates is different every time. you rerun it, the data is for each of the assets it generates is very different, and the lengths of the data and so forth are all very different. It's generating somewhat different calls each time and so forth. So point being, it's very economical. This language is very economical. With just like a dozen or so lines, you can generate some pretty complex and varied tests. But let's get a little more, show you a little more, more ideas of how this works. So here's a little more interesting test here. One really useful line that creates an SST asset with a name, this time not a UID, but a name called the Beatles. I got a lot of 1960s references here to the Beatles and the space program from the U.S. space program. Because I'm an old geezer, so it creates a SST asset called the Beatles with data. She loves you, yeah, 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 and it expects nothing, meaning that it doesn't check for any results. So you don't normally want to do that, but that is an option if for some reason you want to tell it to not generate, to check anything. So it creates data for the Beatles called She Loves You, yeah, 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 and creates it and then does not check for anything because you told it not to. And but it does still clean up after itself. Anyway, yeah, so let's get a little more interesting. I'm not going to do all of these examples cases here, but let's get a little more interesting here. This is an example used to show generating random data. So I say create an SST secure storage asset with random data. And here's what that looks like. It creates a random piece of data, Dum Kahan Fujoffi. Hey, it sounds like coffee. I like that. This time of day. OMAG, yeah, right, okay. All 434 characters of it. So it generally currently generates character strings for its data. I do that as semi-quasi-pronounceable things, well, partly because it's funny, but also because it's recognizable. So if you want to track a piece of data as it moves around through different assets, it's easier to say, oh yeah, that's the Dum Kahan Fujoffi OMAG one. Oh yeah, I remember that. As opposed to some random, who knows what characters, right? It's easier to say, oh yeah, I remember that character string, that data. It picks a UID that at random, deletes it, so forth. So yeah, it can also check. It can also create random names for data. If you want to create a whole bunch of them, you don't care what they're called, it can do that at random. So it created an asset called Ozkapuff this time. Okay. And it generated actually a pretty small piece of data for that time, only 52 characters, and created it. And notice also this time, very important thing, we did not tell it what we expect the result to be. The tool itself figured out what the result would be. Well, it's pretty easy in this case. Yes, it's expecting it to be able to generate that asset, and it errors out if it does not find it. If it does, if it's unable to create the asset, and if it tries to delete it when it's done, and if it makes it that far, it says the test passed. Yeah, let's go on here further. In this particular case, test 6 in this thing here, it's creating 5 assets all in one single nice straightforward line. Creates John, Paul, George, and Ringo. 5 assets with random data. And here's what that looks like. Here's the random data for John, for Paul, for George, for and for Ringo. Creates them all. As you can see, random UIDs, but it cleans itself up on the way out. here, deletes them all, marks the test as completing. Right, getting a little more complex here. This is a test that's really, to be honest, a intentionally badly designed test. It creates an asset and then checks that the asset data is this character stream. Of course it won't be, because I told it to generate random data. So this test I would expect to not work correctly. So it's a badly designed test, but it's just an illustration, right? So it for snort woggle, it creates a 778 character thing called rubmad idjaw. Yeah, right. So it generates that data and then says that it expects it to be almost certainly not this. It creates a buffer for to read the asset data into, and it fills it with nonsense so that if for some reason, I certainly don't want to fill it with the expected data, because if it doesn't read the data, we don't want it to look like it did, even if it didn't. So it fills it with nonsense. So after you create the asset and then read it back, you then compare the actual data to the expected data, and we would expect it to work. But of course we wrote the test badly, because obviously it's not going, this random data is not going to be almost certainly not this. But yeah, right, it's a badly designed test, but it's an illustration. Yeah, so going on, getting more sophisticated. Here is a test that is testing an error condition. So it's negative testing, so to speak, making sure that it behaves badly, so to speak, in a certain bad way. In this case, we are reading an asset that has never been created. So we would expect this to fail. It's going to read an asset called Napoleon. And of course, this won't work. So what does it do? It creates expected data and a buffer for actual data, and then reads an asset that we've never created. And we expect it. The fuzzer automatically says, okay, this isn't going to work, and writes the test saying that we expect it to give you UID not found. And if it does not give you UID not found, then obviously something's wrong with your implementation, your TFM implementation. Actually, in this case, it then compares it to the expected data. I'm thinking that I probably ought to add something that removes the check of the data if it's not expecting the read to even of the asset to even happen at all. For now, it goes ahead and runs the check. Actually, I think the test would bomb out at this point anyway. Test failed. But in any case, I don't necessarily have to generate this if it. Yeah, as you can see, as it's cleaning up for itself, it does not remove that asset because it never existed in the first place. So, yeah. Right, so moving on to, I'll skip a few, go up to 13. Don't have all the time in the world. So here's an interesting case, other than the purpose. This is a deleting assets. We create an asset called George with random data. And we remove it, we remove George. That should all pass, that should all be normal. And then we remove George again. This should fail. Hopefully that's what it did. So we got George data, call, kek, bot, yeah, 124 characters of it. And it creates the asset, and we expect that to pass. It then removes the asset, same UID as you would expect, and expects that to pass. And then it removes that same asset again that's already been removed, and we of course do not expect that to pass. We expect that to fail. So if it doesn't fail, then again, something did not get completely removed within the secure storage implementation, and we'll hear about it. Right, test 16, again, not all of these are all that interesting. This is sort of a more interesting, more random type of scenario. In this case, we create 5 assets. Yes, 5 assets: President, George, Herbert, Walker, and Bush, all with the same data, no new taxes. And we remove an asset, some active asset, one of those 5 at random. So just pick one at random and remove it. And then we do that again. And then we remove a 3rd one at random. And then we delete a random asset that has already been deleted, which of course we expect to fail. Well, what does that look like? Well, here we go. We create, again, I specified that the data would be the same for all of the assets, and generates President, then George, all with random UIDs, Herbert, Walker, and Bush, and then it deletes one at random. Which one does it delete? It deletes President, then it deletes Walker, then it deletes, what are you? You are Bush, and then it tries to delete President again, which, as we can see, is expected to fail. It then cleans up after itself because it deleted most of the assets that it created. It cleans up the remaining ones that it had not already deleted. Yep, getting a little more interesting. This one I should preface saying I think there's a few bugs in this, but this is to illustrate. I think the test generator is not going to do this quite right, but let me show you what this one does. Nevertheless, it generates 3 assets: Neo, Buzz, and Mike, Apollo 11 astronauts. Yeah, again, I'm an old geezer. Neil's data is, that's one small step for a man. He dropped the A, if you may remember that story correctly, because it was 1 a.m. over there at the time. Anyway, I remember that day. But anyway, it initially creates them with random data. Then it picks a number between 2 and 5 at random, between 2 and 5, and then it'll say it's 3 hypothetically. And then it 3 times picks something to do from this list of 4 things to do, and it picks them at random and does those things. And you can see in the verbose output here that it, in particular, it chose to do 4 of those things, again, between 2 and 5, some random number. And it decided to do item 3, item 2, item 3, then item 2. So it can repeat items multiple times with this particular type of randomization. And so it did 3, then 2, 3, and then 2 again. And again, I think there's some bugs in this particular type of randomization. I think I recently introduced them when I cleaned up some code and apparently messed them up a little bit. But anyway, as we can see, I'll fix them. Anyway, it creates Neil, Buzz, and Mike, and then it does 3, which is to, the intention at least, is to remove Neil. Let's see if it did. Yes, it removed Neil. Then it does 2, which is to create Chris and Kraft with data wear the helmet. So it creates Chris and Kraft. It has this 1 in them after them. I don't think it's supposed to do that, but it should be Chris and Kraft. So I'll have to figure out again. Like I say, I think there's some bugs in this particular case. And then it removes Neil again, or excuse me, removes some, wait a minute, yeah, 2. So it, 3 again, so it should remove Neil. But it seems like it just it created an asset out of the blue. So anyway, like I said, there's some bugs here, but I'll fix them. But yeah, that's one kind of randomization. You can set up a block of possible actions and then choose them randomly. Another way you can randomize entire actions is with a shuffle block. So here I'm creating 4 assets, Shiva, Brahma, Vishnu, Ganapati with random data. And then I'm going to do all 5 of these actions in some shuffled random order. And in particular, we can see the, oh, well, in this case, the random order was not very interesting. Let's go ahead and run that again. So the random order in this case was 2, 1, 4, 3, 0. And yeah, let's see what we got here. It creates Shiva, Brahma, Vishnu as expected. And again, there may be some bugs here. I'll have to check it, but in any case, it then does action number 2, which is to reset the data for Shiva to I am the destroyer. And yeah, so it changes Shiva's data. Anyway, point being, it'll do these assets in some random order, and each time you run it, it'll give you a different random order, 0, 4, 3, 1, 2. Run it again, 2, 3, 1, 4, 0, etc. You see the concept. So anyway, yeah, that's I think I probably, yeah, I'm starting to run low on time, I'm thinking here. But so anyway, that's some examples of what I have going on so far with this tool. As I mentioned, so far I've mostly worked just with secure storage. There is code in place for crypto. I have not actually done much testing on it yet, but that's the next step. Well, after I clean up those couple bugs that you saw there. So anyway, yeah, that's a start anyway, and I do have more slides, but I think we're running out of time, so I'll let you move on to next speaker.
Yeah, thank you, Gary. Thank you, Gary. Yeah, it's a very excited presentation and very useful tool.
Even at 1 a.m. or 1:42 a.m.
I don't know, did you realize that many memorable events in your life happens at 1 a.m.?
Yeah, I suppose so.
Yeah, looking on your test cases. Yeah, so I hope this forum is one of them.
Mm-hmm. Yeah, I'm looking forward to working with the community on this. So I definitely like to see if we can get something really super cool going here.
You might need to say something like a small script for me, a large set of code.
Yeah, so
something similar.
Yeah, so I did have this example here, 20, which generates a whole lot of a great deal of test code here. So yeah, it's point being that again a pretty small amount of test code can generate a lot of testing, which is pretty cool. So it's really easy to write tests.
You can feel like Neil Armstrong now.
Yeah, indeed. That's one small step. Okay, go on. Right. Okay, I'll let you guys go on.
Yeah. So let me invite everybody for comments, questions. I think this is the time when you can do it, and also please use chat box for those who feel more comfortable in writing.
Anton, I do have a question.
Yeah, please.
This tool is running in an isolated system, and from what my understanding, right now in this implementation, you have a lot of a combination of text and graphical elements, correct?
And graphical limit, you saying? I'm sorry, you said graphical limit? I'm sorry, what did you say? I'm sorry, say again, please. Sorry, it's 1:45 a.m. Can you ask your question again, please?
Could you repeat the last sentence?
Yes, can you hear me?
Yeah.
Okay.
Yeah, so from my understanding, in order to run this tool, you need a user interface. You need mouse clicks as well as typing stuff around, correct? Can you run it fully from a command line?
Yeah, so it is strictly a command line tool. So here, this is the command here down at the bottom. And it is strictly a command line tool. That's just run that test and it generated that test. This again is just a simple little shell script that runs this this command here, and it generates. I'm just showing what the code it generated. This is just a generic text editor. Nothing as it creates the file, and just showing you what the file it generated, the text file it generated, that it's, the compiled code or the code to be compiled for the test. So it is strictly command line based.
Okay, so it is quite easy to interface with other CI solution, for example.
Mm-hmm, yeah, absolutely. And that was part of the reason why, at least initially, I wanted to work with a host workstation-based tool, because there's a completely working infrastructure for regression testing, and this just generates tests like any other regression test that we have it uses the exact same infrastructure that we already have. So I wanted to leverage that as much as I could.
Okay,
Sorry,
thank you. Yeah, yes, thank you very much.
Okay, great. Any other questions?
Yeah. Any other questions? Then,
so where are the folks from China? Where are the folks from China? I'm curious.
I have a question. So if you catch some bug or some, I don't know, issue or test fails, so is there a way to reproduce the test? So
yeah, so good point. Yes, or good question, or both. Yes, so this is very, as you can see, as it runs the test, in this particular case, it just picked a seed at random because I did not specify a seed. You could alternatively put a seed here right after the output file here, and if you do that, it will reproduce the test exactly identically every time. Well, assuming that you don't modify the program, because obviously it'll, all bets are off if the code generator changes. But assuming you're running the same version of the code generator, then the same seed will always produce the exact same test. If you don't specify a seed, it will choose one at random based upon the time. And I think actually, oh, okay, yes. The plan is for it to generate a new seed based upon not only the time, but also XORing the time. The plan is to XOR the time with the PID of the process that's doing that, that's generating the test. The reason why I want to do that is because if you're running multiple processes that are generating a whole lot of these tests, if they both happen to start the test in the same second, then they would generate exactly identical tests. But if you XOR the time with the PID, then you'll get a different test every time, on every instance that's running them. So if you want to generate a whole lot of tests en masse, so to speak, you can fork off multiple processes generating tests, and they will all generate different tests that way. But yeah, so it's reproducible. Yeah.
okay, and apart from that, is there any login mechanism? Obviously,
Well,
we can catch the screen and capture the output screen and put it in some log.
So basically, that's just leveraging the existing mechanisms that we have. It simply generates tests like any other. So the log files are just exactly like any other regression test that we have. And we could generate, if we want to, we could create scripts that would parse the log files as needed for if that's of use.
Mm-hmm. Okay, thank you, Gary. Any other questions?
One quick question. Hi, I'm Vishnu. How about the scalability? As in, let's say if there is another interface that has been added, BSA interface, does it work?
Interface.
Yes.
Interface in the sense of like
a PSA interface, basically.
Like an additional secure partition or that kind of thing, or
for example, any new PSA APIs that has been added, and if you want to generate a test for that.
Okay, so the intention is to create a tool that can do the off-the-shelf PSA first and foremost. One thing that I think we can pretty easily do, and look forward to making provisions for, would be, as I alluded earlier, we could create some sort of a plug-in mechanism that can allow people to create stimulus for extensions to the PSA APIs and exercise their secret sauce, so to speak, simultaneously with the PSA functionality, the off-the-shelf PSA functionality. So that is a possibility for how that could be done. But yeah, we're open to possibilities along those lines. We can talk, so to speak.
Thanks.
Thanks, Gary. Any other questions?
I'm just curious, where are the folks from China?
Oh, I can see many.
Oh, okay, cool. I just see something called trusted firmware, so maybe that's the folks in China.
I hope.
I think there are many attendees on the call who might need some time to process the information, and we might receive queries later on the mailing list. So, yeah.
Okay. I'm just curious. 因为我太太是哈尔滨人。Sorry. Now my wife is from China, so I always love to brag that I can speak Mandarin. Anyway, sorry, I'm babbling.
Yeah, right. And thanks, Dash, reminding that another channel and to ask the question is after this open call. You can use the open mailing list, so you can refer to this call and ask more questions.
I will go ahead and post the slides, of course, as well into the, yeah.
Yeah, and slides will be shared as well, yeah.
I also mentioned that just, at least for us in ARM, there is a reference in the slides, there's a Confluence site that talks about it. So just mention folks within, just for folks within ARM currently, that well, I'll see if I can find some way to make that visible to everybody, but at least within ARM, you can see a Confluence site that talks about it. Anyway.
Gary, I have a question. What is the plan of releasing this tool? What is the timetable we're looking at?
Shall we take queries for schedule offline and leave this session to mainly introduce the tool? Okay, sorry.
Okay.
Thank you.
Okay, so we have only 8 minutes.
I'm sorry, I better stop sharing here. Okay.
Yeah, that's fine. That's fine. I think in the 8 minutes, it would be hard to cover the another topic. So that
sorry,
I
guys. Sorry, guys.
no, thank you, Gary, and thank you for very good presentation. And considering 1 a.m., I can only imagine what would, yeah, it would like it would be a good time for you. For the second topic, let's postpone it for the next week. I could suggest or ask Minos if you can make some 2 sentences describing what is it about, kind of teaser, and then we can close this forum.
Yes, the topic is something that Thomas discovered and he mentioned in the mailing list. So we could use the mailing list as a way to communicate in between this and the next forum anyway. But this has to do with certain assumptions that we take that the compiler would do. And according to the standard, it is not guaranteed that the compiler will do what you expect. So this expresses itself in different ways, but most namely, this causes problems with the SFN section, which is something that we have already marked as we will fix. And this was a temporary solution to begin with. But this will describe more about the problem and how it can realistically affect us the more we move to level 2 and level 3 isolation. And yeah, this is pretty much it.
Yeah, thank you. I think it's very, very important topic, because even if you do all measures to your security, the compiler may have different assumptions and do it differently. and even more, different compilers will do it differently. So I think it's worth to be aware about it and discuss it within the community.
Yep, I don't know if Thomas has any comments or you would like to share anything about his experience trying to port the IR toolchain.
No, the only issues I've had with the SFN section is for our compiler that it may generate initializers that end up in RO data, which is not in the SFN section. So the RO data ended up in another section, and I got hard faults when I tried to execute that. So I've manually placed the RO sections in the secure section for now, but I think that we should address this in some way where we can keep the code and RO data combined somewhere. So I haven't thought of it much.
Yes, this is exactly what I have managed to reproduce, and I have managed to reproduce it with both GCC and ARM-C-Lang. So it will become more and more evident the more you start trying to isolate your partitions in the secure side.
Gentlemen, you are going to details and spoiling the interesting topic.
Okay, let's talk to it next week. Sorry.
No problem. It's interesting. Well, anybody wants to add something or discuss any topic, please put your interest and put your questions to the mailing list and it will come as an agenda to the next technical forum, so where we can discuss. So I do encourage you. Second thing is I asked for a feedback of the user experience of the TFM. So far, not many arrived. So this call is open. Please share your feedback, your difficulties or your problems, the things you think are very good, things you think could be better. Yeah, we are looking for this. That's all from me. Thank you, Gary, for the good presentation. Thank you, everybody, for the participation.